identity. And therefore, this system exactly the same as this system. Right? In the input-output sense. And therefore, this is still PR. And this is a PR system. Right? In particular, what if I use 1, 1, 1 minus 1? What's the invert of that matrix? 1 over square root of 2, okay? Put 1 over square root of 2. What is that invert? 1, 1, 1 minus 1? One minus one is square root of 2, right? This time this 2. This time that is 0. This time that is 0. This time this is 2. This is orthogonal. This is orthogonal matrix. Transpose will be the inverse. Right? That's easy way to see it. Anyway. Have we seen this before? Have we seen a system with 1 and minus 1 before? That's a hard wavelet. Let's think about it, okay? I want to move this block this side. Move this block that side. I want to show you that this is the polyphase representation of the hard wavelet that we have discussed before. Okay? So I'm going to do the reverse way. Going from here to there. Okay? So this is a constant, it doesn't matter. Z to J, right? So this block will come first. So I'm going to have a block here with 1, 1, 1 minus 1. The inverse. Now by 2. Now by 2. This guy is on the other side, okay? One, 1 minus 1. And square root of 2 somewhere, right? Okay? Okay. This is for reference only. This is the conventional way to draw a two-channel filter bank. You have seen this many times, right? We split into 2 branches, we combine them. Okay? This is a new way, polyphase way of looking at the same thing. Okay? This is the polyphase form. And this is the equivalent of the polyphase form. Because this is a constant, when you move it, it doesn't go up 0 to the m, right? It's a constant, stay constant. So tell me, what is h naught of z, h1 of z for this system? How do I find h naught of z? Here, the transfer function from the input to the first downsampling. What is it? What is that transfer function? 1 over square root of 2 and what? 1 plus e power c. How do I see that? So I want to erase this and draw this in the branches, okay? What does 1, 1 means? It means that this path is 1 and this branch is 1. Right? Okay? You have a matrix 1, 1 times vector, right? A and B. A and B is right here. A and B. What do I see? I see that 1 times A, 1 times B. So 1 times A, 1 times B. Okay? So when I draw a matrix, like that, you have to visualize that in a signal form. It's going to be like this. Right? And 1 minus 1 is 1. In a signal form, what do I get? 1. And this is minus 1. Okay? That's signal form. Is that clear? So from here it's very clear, right? The transfer function from input to the first downsampler is 1. Forget about it. The square root of 2, okay? It's 1. The inverse 1. How about the second branch? What's H1? H1 is from input to the second downsampler. What is that? 1, right? Minus the inverse. That's what we see in our vector, right? If I average and difference operation. How about F naught? F naught, right, is from here to there. I'm going to erase this again and drawing this, right? So 1. Okay. What is F naught of Z? And F1 of Z. F1 is square root of 2. So what is the transfer function from upsampler to the output? Right? So it's still 1 plus the inverse. How about F1? From here to there. There's a minus 1 and plus the inverse. Okay? So minus 1 plus the inverse. And we know that R is both linear phase and orthogonal. H naught and F naught are exactly the same, right? A linear phase is symmetric, and they have a 0 minus 1, 0 minus 1. They're also orthogonal. What is P naught equal to? How do I find P naught? How do I check to see whether this is PR? One of the check is the P naught is a half band filter, right? With R, L, we're done. Right? So what is P naught? It's H naught times F naught. Right? It will be 1/2 1 plus the inverse square. And that is half band. I mean, we start today with this example. Okay? So we become full circle today. Right? We start with an example, we decompose to get this form. And then we use polyphase.